Okay, so now let's talk about the actual natural base e. So e is an irrational number, and it is defined as x approaches positive infinity. Then it is going to approach this value of e, which is 2.7182, etc. So a way to kind of remember what e is it's very similar to pi. Pi, is the relationship between the circumference and the diameter of a circle. And any time, it doesn't matter what size of circle we have, pi is always going to result in 3.14, etc., etc. So it's very similar. E is that constant of 2.71. So when we graph e, when we take e and we raise it to the x power as an exponential function, if we look at a graph, if we compare these two, so my red graph here is going to be e raised to the x, so it's raised to the positive x. Notice that's an exponential growth. That looks just like exponential functions because the x is up in the exponent, and my base in this case is that 2.7182. So our b value is this e right here, which is that constant term. It's never going to change. And then when I change it and I make my exponent negative x, notice it's my green graph and it's still exponential, but now it's a decay. So when we're talking growth and decay with our natural base e, a growth is when that exponent is positive, where a decay is when that exponent is going to be negative. So if we go back to here, if we look at some examples, so we have e raised to the x. Well, this is going to be a growth because that x is positive, where over here we have negative 0.5x, so the exponent is negative for e, so this is going to be a decay. And then graphing the function, I'm not going to physically graph it. If you guys are at home and need to graph it, you can type that into Desmos, or if you're at school, you can use the graphing calculator. Here's some more examples. This one would be a growth. This one would be a decay because that x is negative. This one, that's a positive 2x, so this would be a growth as well. Okay, so E represents a continuous growth. So a lot of times when you invest money, the money can grow or can compound continuously. So when we compound continuously, we have this equation, y equals E raised to the RT. And you will hear me say PERT because that kind of looks like PERT right there. So anytime you see the words in a problem compounded continuously, you're going to use PERT. So we've talked the last couple days about compounding problems where we compound quarterly or monthly or weekly. We don't use this formula when we hear those words. Only when you see this word continuously are you going to use this PERT. So P is that principal, which is always how much you start with, like what are you investing? And then R is still your rate and T is still your time. On your calculator, you're going to have a button for E. And if you're at home needing to do a problem, you can always just type it into the Desmos and just use E on your keyboard and it will do the correct E. Make sure your rate is as a decimal, just like in all of our other problems. And then your time is just whatever time it gives you. Okay, so let's look at some problems here. So you and your friend each have accounts that earn annual interest compounded continuously. So there's your keyword there. The balance in dollars of your account after T years is modeled by this equation. So this 0.04 T, that's in the exponent. And then the graph is where your friends are over time. So it says, which account has a greater principal? Well, remember, our P is what we start with. So for you, if we look, you are going to be starting at $4,500. And your friend, if we look at the graph, remember our starting amount is when we're at x equal to 0. So the graph starts at $4,000. So your friend starts at $4,000 and you start at $4,500. So you have a greater principal. So then it says, which has a greater balance after 10 years? So in your equation, I'm going to have 4,500 times E, and I'm going to raise it to the 0.04 times 10. Like, we're going to put that all up in the exponent. And then you're going to type this into your calculator. The E on your calculator is the second function of natural log. So it says ln, that's the button. And then above it, it says E raised to the X. That's going to be the button you would use to type this E in. And when you do that, you get $6,713.21. So you have, after 10 years, you have that amount in your account. Well, after 10 years on our graph, if we follow 10 years, here's the intersection, and it looks like you're going to have just over 7,000. So we'll just say about, or not you, your friend is going to have about 7,200. Let's just say roughly, just reading that graph. So your friend, like, you have the greater principal, but your friend ends up getting more money over time because of what they have invested. Okay, let's look at one more problem here. So you deposit $4,250 in an account. It earns 5%. Again, I'm compounding continuously. So I'm going to use PERT because I'm compounding continuously. So I start with $4,250. And then I have E, and I'm raising it to 5%, would be 0.05 times 10 years. Make sure when you type that, that whole thing is up in the exponent. And then when I type that in, I get $7,007.07. So after a continuous growth, after 10 years, I have just over $7,000. And then I'm not going to go too much into the graph of this. You guys can just type this into the calculator and use your table of values. So if I typed this into the calculator, let's see, at 0, it's at 2, at 1, it's at roughly 5.4, at 2, it's at 14.8. So then you're just plotting those points. So at 0, 1, I'm at 5.4. 2, I can't even go that high on this graph. It's kind of hard to graph. But then there would be your graph. So just remember, it is an exponential function, so it should have that J figure when you're graphing it.